Alright guys, what's up? So today I'm going to be talking about math because I left my math lecture because I was already behind learning about limits. For some reason I just didn't get them. I was like, man, what? That's weird. And for those of you that don't know what a limit is, it's basically like you take a graph and you want to find what the limit is. Normally it's like if there's a hole in the function, right? If there's like a nice little hole or something, you're like, man, what's the limit of this thing? So like, let's look here. The limit of like where it would be when x is would just be like right there. And I know that that's an awful explanation and it's going to make no sense. But that's okay, because I'm not here to explain limits. I'm here to explain continuity, because the class that I missed was continuity, because I like left halfway through because I was like, I don't want to be even more confused. Because honestly, my teacher cannot explain things well. He's just not good at it. So we're going to be talking about continuity. And so continuity is exactly what you would expect. You take a graph and you find where it's discontinuous, where there's a hole in it, maybe like it just doesn't work. Like right here, we got these are the four types. You got removable discontinuity, which is just like you got a hole in it. So it's not continuous because there's a hole. It's going, and then like f of x for whatever this function is doesn't exist. It's just not there. It's like, yeah, peace out, see you guys. And then we have infinite discontinuity, and so right here, these things are never going to approach the y-axis. So that point doesn't exist. Like f of 0 is never going to exist because these things are, okay, well that's not 0 since that's the y-axis. But they're never going to approach whatever this is, whatever a is. So f of a, it's never going to exist. So that also is discontinuity because the line, if we were to just like look at where the line's going, it goes and then it just isn't there. It just stops existing and then it goes again. And then we have jump discontinuity, which is basically like, I mean, you see the graph. It goes and then it's like, yeah, I'm gonna go down here. And so even though it's still technically moving constantly, because this area does not line up with this area, it's discontinuous. It is so, yeah, and then oscillating discontinuity. I have never seen a graph look like that. Like, we haven't gotten that far yet. I'm sure that that's probably like what today's lecture is on or something. Because I don't know, man. They do that, I guess. Lines do that. And if there's a bunch of different lines and you can't read it, then it's like, well, I guess that it's discontinuous because it could be multiple things. Maybe, I'm not sure. I haven't learned that yet. Don't take my word on it. So these are the three basic types of discontinuity that we're going to be talking about. And so that's continuity right there. That makes sense. And so now we're going to look at a couple of continuity questions. And now I have not prepared these ahead of time in very Chad McGee fashion. So we're just gonna just click on random things and see if we can get something that we can solve and be like, oh, let's look at how we do this. Yada yada, all math speak. I don't really speak that. Okay. So this is not continuous. So when you look at like an a like normal function and it's a rational function, so it has something at the bottom, and you're like, oh man, so the very bottom of it, like, can't equal 0. Does that make sense? Like let's say that, I don't know, for this, um, sorry, I'm trying to do the math in my head. So for this t can't equal 3, and it can't equal negative 5. Let's say it equals negative 5, okay? We get 25 here minus 2 times 5, which is 10, minus 15. So 10 minus 15, or negative 10 minus 15 is negative 25. And then, t squared, which is positive 25. So 25 minus 25. So that means that the bottom would be 0. And that's not allowed. That's a big no-no. You can never divide by 0. If you guys remember Slope Guy, if you ever watched that video in algebra class, and if you didn't, shame on you. You have like no childhood. That's just sad. Leave this video and watch Slope Guy right now. 'Cause yeah, you can't divide by 0. Or maybe you can, but we just don't know that you can yet. Or I don't know that we can yet. I don't know, man. 0's weird. 0's just a funky little number. It means like literally nothing. I just gave myself an existential crisis by saying that. But yeah, anyways. So if we were to look at the domain of this, you would have negative infinity to negative 5, because once you get to negative 5, it doesn't like exist anymore. Like it can't exist. And then you would have a union between negative 5 and 3. Because the other thing it can't equal is 3. You get 9 here. This equals negative 6. Why can't it equal 3? Wait. I don't know, man. I don't know. Oh, negative 3. Right, it can't equal negative 3. So negative 2 times negative 3 is going to be positive 6. Plus 9, that's 15. 15 minus 15, 0. Doesn't work. That's a no-no. You can't divide by 0. So you get parentheses negative infinity to negative 5, end parentheses, union negative 5 to 3, end parentheses, union parentheses 3 to infinity. That's the what's it call it? That's the, I forget what it's called. Now let's pull up Desmos and look at what this is going to look like. What this graph is going to look like, and then we'll be like, oh, well, this is this thing. We'll look at what type of discontinuity it is. Please let me just copy this in. It's not going to. I'm not even going to try. It's just going to be weird. Called it. So 4t minus 10 over, oh, I need to set f of x. And then bottom t squared minus 2t minus 15. Should have been f of t, my bad. There we go, okay. So it's a little funky. It's a little strange. And you can see that this is a infinite, infinite discontinuity at negative 3 and 5. And it's like, whoa, that's crazy. So that is, so far, the questions that I've been doing. And that's very, very basic discontinuity. Yeah. I hope you enjoyed. I hope maybe you learned something, or maybe you didn't and you already knew it and I just explained it really poorly. Or maybe you didn't know something to begin with and then I explained it so poorly that you didn't know anything to not begin with at the end of it. So that's, you know what, whatever the case might be, I hope it happened. Chad McGee, out.